Come back. Now let's study general logarithmic functions. Recall for any base b greater than 0, b not 1, we know log base b of x is natural log of x divided by natural log of b. So natural log of b is a constant because x is the variable. Okay. So derivative with respect to x of log base b of x is that constant stays away and you need to take derivative of natural log of x. But this we already know. It is 1 by x. So derivative with respect to x of log base b of x is 1 by x log base b, natural log of b. So, okay. So this gives us an example. Find the derivative. Fx is log base 3 of 2 plus x squared plus sine x. So this calls for chain rule. First, log base 3. You are going to divide by natural log 3 when you take the derivative. Right? 1 by natural log of 3 times derivative of natural log of 2 plus x squared plus sine x. This calls for chain rule. So don't forget 1 by natural log 3. Then derivative of this quantity, the argument comes down, and by chain rule you are going to take its derivative here, 2x plus cosine x, and that's that. So that is derivative of general log base b. Now let's go to general exponential functions. For any base greater than 0, you know the function fx equals b raised to x. You know that this is differentiable. Okay, by the way, here b can be equal to 1. That's okay. So what is the derivative here? Derivative of general exponential, if you remember, you have a factor of derivative evaluated at 0 times your same exponential back. F prime at x is f prime at 0 times b to the x. What is f prime at 0? It's derivative at 0. F prime at 0 is derivative at 0. So you're taking the limit h approaching 0, f at h minus f at 0 over h. So that's what is b to the h minus 1 over h. Now, b raised to x is e raised to natural log b of x raised to x. So you see this is a general base. B raised to x, b itself is e to the power natural log b. Power x is power x. So what happens when I take derivative here? Well, this derivative is the same as this derivative. Exponent of exponent. So the powers multiply. Derivative of e raised to x, natural log b. But this is exponential function. Derivative is itself, and by chain rule, derivative of this. Derivative of this with respect to x is simply constant natural log b. So all you have is e to x, b natural log b, which is back to b to the power x. And derivative here is natural log b. So what do we have? Derivative of exponential function is b raised to x itself times natural log b. What happens when you're taking derivative at 0? Just substitute. Derivative of exponential function is natural log b. Now this is fantastic. You see, here is derivative of general log. When you take derivative of general log, you are dividing by natural log b. Otherwise, it is like taking derivative of natural log. Whereas in exponential, derivative of exponential is the same exponential function multiplied by natural log b. All right. So this last result gives you an immediate conclusion. You see, divide both sides by natural log b. So integration of b to the x is b to the x over natural log b plus constant of integration. So this is general result for integration of exponential. This is general result for derivative for exponential, and this is general result of derivative for logarithmic function. Okay, general. Now let's come to logarithmic differentiation. The technique of logarithmic differentiation. This is an important technique. We have already seen its use once. Let's see it again. We want to use, this technique is used to differentiate some complicated functions. For example, fx equals all of this. X power 3/4, fifth root of x squared plus 7, the whole over cube root of x squared plus 8. Find its derivative. You could, in theory, in practice, you could find the derivative using quotient rule and product rule and so on and so forth. It's unnecessarily complicated. You can use instead natural properties of the natural logarithmic function. Set y equals all of this. Take natural logarithms of both sides. Natural log of y is natural log of this entire expression. Natural log of y is, now you can use properties of natural log. Natural log of the top minus natural log of the bottom, and then the exponent starts coming out. So notice there is a product here. So there's natural log of the first factor plus natural log of the second factor minus natural log of the denominator. Now first factor had power 3/4, that came out. Second factor had power 1/5, that came out. And denominator has power 1/3, that came out. So that is natural log. So notice now this is quite straightforward to take derivative. So take derivatives of both sides with respect to x. So left hand side, notice this is a function y, which is in terms of x. So derivative of natural log is 1 over y. By chain rule, you need to take derivative of y itself. So y prime over y is 3/4, 3/4. Derivative of natural log x is 1 over x plus 1/5, 1/5. Derivative of natural log x squared plus 7, x squared plus 7 comes down, and chain rule, derivative of x squared plus 7 is 2x, that's upstairs, minus 1/3, 1/3. Derivative of natural log 1, x to the 4th over 8, x to the 4 over plus 8, comes down, and derivative of x raised to 4 plus 8, that's here. So this is y prime by y. So y prime is, just multiply by y to both sides, you get y prime is y times this entire expression. But what was y? Y was precisely your original expression. So y prime is your original expression times this expression. So notice how neatly you can find the derivative using properties of natural logarithmic function.